And it's my real pleasure to introduce our next speaker, who's going to be in person here in the studio. Lewis is the ex-head of data science at Dyson, now director of data at the GoCompare group. And Lewis is also part-time reader in the computer science department at the University of Bristol with research interests in deep learning for search applications. So perhaps he and Andre need to have a conversation later on. Anyway, so Lewis, as I said, is here in person in the studio. Over to you, Lewis. Please do take the floor.
Thank you, Nick. Well, thank you very much for having me here. I'm going to be talking about something that is related to everything we do in data science and MLOps in general, right? Which is how we try to deliver impact to our business, right? And I want you to focus on a number. If something sticks to your mind today, let this be it, right? 87% of the time, we fail to deliver data science in production, right? And why is that? Are we stupid? Are we clumsy? Are we not doing our job properly? I guess it's just because it's very difficult to do it. And the key is probably trying harder, right? I guess the organizations are thinking, well, you try to deploy one model and you fail, right? 90% probability of failure. You try to deploy 10 models and you succeeded one. That's not quite enough to see business value, right? So some companies are reducing investment in AI and they claim AI winter is coming. We've seen this before, right? I am not terribly scared this is going to happen again. I would say I come from a part of the world where winter is actually manufactured. We export it globally. So I know what winter looks like very well. I don't think this is the case. And what we've seen this morning in all the presentations is great tooling that is actually transforming the landscape. It's making us more capable of trying harder, right? If we deliver 100 pieces, 100 models in production every year, and we only succeed 13% of the time, that's still fantastic, right? We have deployed one model a month, roughly, and that's surely transforming our businesses. And you guys are a part of this revolution. You are making this happen. I'm really enthusiastic, and I wanted to share with you a couple of things, a few reflections on important elements, mainly around provenance, but I'll be touching on a number of things as I go along, right? So, 2080 rule, right? How many times have you seen your data scientist telling you this? I am sick of dealing with infrastructure. I'm cleaning the data. This is not what I should be doing, right? I think we can hear that every day a few times, all of us. But that's not very different, right? Come back with me 20 years and any web developer would tell you exactly the same story. I'm coping with the browser. Some things may not change as much. Internet Explorer may not be great even today, but it is still about abstraction. What these people complain about is the level of abstraction they have to deal with to do their job, right? And we have gotten great in terms of web development, for instance. There's plenty of tools. You don't need to be a programmer to do your own website, and you guys are pushing the limits to do that, right? Data scientists won't have to be experts in infrastructure to make this happen. And this is kind of the journey that the software industry went through to make this massive exponential impact, right? Initially, there was the compiler, and sorry to go back many decades ago on this one, but the compiler was a revolution at the time for them because it could let them deliver genuine warranties on the product that they were creating, an executable, right? And that executable was all of a sudden distributed at large scale across different areas of the business. People were using it. And that in itself caused some other problems, right? Which is how do you collaborate? So version control came in, and then further collaboration, bigger projects, bigger teams is a virtuous circle here, right? Where you just see more and more effect on the business, piling up little by little, until you reach that inflection point which is in between the version control, blue box in your slide, and the process and organizational changes. Right? I think that's exactly where we are today in the MLOps community. You guys have pushed the tools to a point where we are accepting a reasonable level of influence on processes and organizational changes, and we are only going to see this thing accelerate and go faster, right? Is it anything like a software at all, right? There's some similarities, there's many differences, and we've seen quite a few throughout this morning between data and data science, machine learning, and software, right? I think there is, right? I think there's many commonalities, and when I think of a compiler, and again, think of a compiler as in a very simple way, right? Something that puts together chunks of code and then spits out an executable program that you can run anywhere independently of the machine, right? The first stage on a software compiler, you have it there on the left-hand side of that slide. It's a lexical and syntactical analysis. What that means in plain English, in English language, would be a red cat, a sentence like that. You'd be analyzing 3 words. Is an article, red adjective, cat is a noun, right? Something that is very simple and quite formal. Basically, our teams in data are doing this every day. They do it manually. They analyze the quality of the data, the metadata, and even the output or the model data, right? So that's not great. We have thrown lots of automation, but still there's a level of manual process involved. The next stage in a software compiler is semantic analysis, right? I'm obviously simplifying a little, but bear with me on that one. Semantic analysis is about understanding relationships between elements in the code. And in data land, that would be understanding your business, right? The data generation process is sometimes critical for what you can do with the data. We need to understand what variable X means for the marketing team, or maybe that variable means something different for finance, right? And that understanding is essential to everything we do. Again, very manual, labor-intensive process that your data science team tend to do, or even your data engineers sometimes, right? Then, if you're lucky, right, and I guess many projects die here, we realize that the project is not feasible to start with, and hence that 87%, you do some code generation, and that can be a pretty dashboard for classic BI teams, or it can be a more advanced machine learning model. But that's the next stage also in a software compiler. And finally, there's an optimization phase in both compilers and data pipelines, which is about making that strong and robust and failure tolerant, hopefully self-healing. Ideally, the compiler should be more robust than the software or the data it compiles, right? So it kind of looks like a compiler in a way, right? So the only thing is the compiler is difficult. I'm sure you're sick of seeing this slide all over the place, right? The colors here mean different people, different roles, doing different things in putting this jigsaw together, right? I want to explore a little what's the state of the land for this tool, right? Classic tasks for a data scientist / machine learning engineer there, and how they happen in public clouds, and I have 3 of them, or some private companies. I have 3 of them off the back of that paper there. But you can see black is good in this slide. So lots of black all around. That means that training and authoring tools tend to be quite well covered. Sometimes cheekily so, because it's just a wrap up on other open source tools, right? But it seems something that is at our disposal, and again, it's to your credit because you've been building this for a while. So thanks for that. The next one is about serving and deployment, right? And we've seen a few this morning as well. And again, it's not as black as it was before. Lots of gray areas there, especially on the public cloud serving part of it. But I would say is still in a very good shape. What happens when it comes to data management, right? And that includes data provenance, testing, feature stores, labeling, including something like active learning, right? You see that there's lots of white spaces in the public cloud offering. Why would you say that's the case? I'm not an oracle, right? But I guess my simple explanation to this is that data management is way more complex than many of the other things that we do. And it is more complex only because it's more intrinsically related to the business and the business problems that we are tackling, right? So I'm going to focus a little bit now more on data provenance and data testing, right? Just because they are key ingredients in terms of data management. In software, we do really well-defined tests, right? They are very creative, but we have good recipes and good tools to deliver these tests at scale, right? What happens in data land? Well, I'm oversimplifying here again. What you see there in gray is data stores, right? In black, you see software processes. Some of them are classic pipelines, some of them are machine learning model. It could be just additional transformations to paint a pretty dashboard somewhere. Where do we test here? And what's data provenance, right? What does it mean? Well, data provenance, I always think about it as Tom Thumb dropping breadcrumbs as he goes along, trying to get back home, right? The only thing is that in data, in machine learning, we want to offer engineering warranties to everything we do. Otherwise, the birds can come in and eat the breadcrumbs and we'll be lost. How do we do that? How do we make sure that it's not just about data lineage. It's not about just knowing where the data is coming from. It's about making sure that the data, the final output is reliable and we trust it all along these transformations, right? Well, initial one would be classic software testing that happens in your software pipeline. If we are not doing this, that's something we need to think about very seriously. But I'm not going to stop there. I want to focus more on the data aspects, right? And data validation is one that I feel really, really happy to talk about, right? It's mainly about schema validation. Many companies still don't do schema validation, believe it or not. Essential, in my view, also about trends and anomalies, right? If you're not doing that, you may be missing out and some bad things may happen. You may ask, what if I use unstructured data and it's all about text, right? Still, there's many things that you can do in terms of making sure your entities are there and well-known entities. Maybe you have a knowledge base and you can map that data to your knowledge base and enrich it as you detect new things that were not there or new relationships that happen in your text. So the next one would be about, well, we have transformed the data. Our raw data is valid. We are pretty confident about the format, and our pipeline is super duper well tested. We trust the output of that one. Now we need to feed it into the next phase, probably a machine learning model. How do we go about that? What elements do we need to test to make sure that the birds are not eating the breadcrumbs, right? Bias in the data. Is the data representative of your population? What's your population, right? Some basic questions. Feature distribution, skew. The data scientists tend to analyze this every single time, right? Feature stores are very helpful, but many data scientists do the exploratory data analysis every time. And it's stuff that should be highly automated, and we can definitely do that, right? Just as an example, coming from Airbnb, you see that latitude and longitude are not normally distributed. And that, for many models we use today, is not a great starting point. But there's an easy transformation that you can see at the bottom of that slide that would transform that data into normally distributed. And that's great, because that means that we can use it. But what if the data changes over time, right? New properties appear in Airbnb or disappear, and the distribution changes, and you cannot transform it with such a simple transformation. The model may be spitting out an output without you noticing that the distribution of data has changed. And that's not exactly what we want, right? If we want to offer those engineering level warranties. I'm sure you will get sick of me saying or mispronouncing engineering level guarantees, but here I come. Then, after we have done that homework, it's about testing the machine learning model. And at uni, I get lots of students asking me, how do I test my machine learning model, right? Is it like software testing? And I have to confess my ignorance to some extent there, right? In that I don't have a clean-cut answer to give them. But one of my recommendations tends to be use your schema and your anomalies and try to feed those into the model to see how it behaves. Use a schema-led fuzzing so that at least you would know that, you know, within the range of valid data, your model is behaving, even if the data is not common in your user base or in your data set. Then next question is about the model, right? And you see we're following these linears, this provenance of data from the raw data all the way to the output, right? But then we can open the lid of the model, we can open the cake and disassemble it in layers. So many tests that you can do. You can apply any of the many explainability frameworks. Some of them are not just black box frameworks and you can really understand what's going on inside. But in some cases, you can even look at the distribution of the features from the input features all the way to the output in a deep learning model and see if that distribution looks like smooth and pretty, like the one in the slide, right? That tells you that things are working okay in a model at a general level. There's plenty more examples that you can apply there just to understand the impact of some features on the output, right? Finally, we have reached the end of the pipeline, and obviously you want to see what's going on with your model, right? No question about it. When people think about monitoring, sometimes they stop at monitoring the output of the model, and as good as that is and as necessary as that is, that's clearly insufficient, right? Data provenance is about offering that end-to-end guarantee that things are going well and you can trust the output. So ideally, in a monitoring dashboard, you should have the output metrics that are relevant to you. Ideally, the business metrics, the KPIs, those technical metrics are making an impact on, and all the data validation, data input, and data analysis metrics. You need to understand end-to-end what's going on. Of course, bonus points if you include operational telemetry from the underlying infrastructure, right? And I think I've seen hard drives failing in a data center affecting the performance of some machine learning models, and we were going nuts to try to figure out where those problems were coming from, right? Sometimes it's difficult when you don't have the right tools to observe what's going on. Testing is great, but as great as it is still a bit of an art. And you can see this example from Uber, just 4 dimensions. But when you combine those dimensions, you may end up with millions of tests if you want to do this the right way. What that means is that just one piece of advice: hire the best people you can, because they are not going to be testing millions of things. Otherwise, that 87% is going to be 100% or basically zero, because you will not be able to deploy anything ever. So this takes me to the next part, right, in this journey towards exponential impact, which is fine. We have a pipeline compiler. We have tested the thing. We know how things work end to end. We rely, we trust the output, and we are confident that everything is working and everything, all of our assumptions and invariants are still in place. But as Luke was saying this morning, right, I'm basically cheekily quoting and copying his face here, is there's a big problem there, and it's data version control. He was presenting some of these elements. What's different? The data now, right? It's not like software version control, because we need to take care of the data, the metadata, right? All of those hyperparameters, the architecture of the model, and then the model itself and how you wrap it up to serve it in production. You wrap it up with different runs and experiments, and you join in your live users. Say you do A/B testing before you deploy in production for real, right? How do you package all that together and manage that as a comprehensive single unit, right? And also the way we approach data from a more abstract way is also different, right? We tend to rely on the scientific method. Data science is called data science for a reason, right? It's about reproducibility, lack of bias, and explainability, as basically was discussed this morning. So it's a difficult landscape, but hopefully and luckily we have many tools already there. Again, Luke mentioned this morning. You have an example here. It makes me laugh and it makes me angry at the same time. That's an Excel to track your experiments and all these combinations. this, the Spaniard in me suffers, and I'm calling for the Spanish Inquisition to come and punish this cardinal sin. If we want to offer engineering warranties, we cannot use Excel, right? And that's the whole point. We need to make our users, our businesses, trust what we deliver, and we need to fail comfortably. And what that means is we need to fail 100 times to succeed just 13 times, right? Remember, 87%. So, in my opinion, we have reached that tipping point, that inflection point in the curve, where we are starting to see some dramatic changes in some companies. Other companies are just trying, which is the way forward. But there's a third element, right? It's a third element that we haven't considered. It's not just about tools. It's not just about the version control. It's not about seeing things end-to-end in that provenance. It's about how timely we are in introducing our tools. It needs to be the right tool for the right team, for the right company, right? All at the right time. Otherwise, we may end up in difficult situations. So in general, it's a journey, and all companies tend to go through this journey. You wouldn't put that child there to drive the car, would you? Otherwise, I guess it may not end up as you expect, or maybe it would. But it's ideally about balancing three main axes. One on tools and teams, back together. You had a massive team with no tools, difficult situation, or the other way around. You bought a massive cluster of X, Y, Z technology, but the team don't trust it, don't know how to use it, not going to end up well. You invest in business relationships, but you don't have the team to deliver, right? Cool. People will love you for a while, but then you don't deliver, so trust will disappear very quickly. And if you don't think about your processes early and how your data science, machine learning efforts map into key business metrics that the business decision makers understand, then again, the trust will disappear. So you have that diagonal blue line inside that cube. And I think that's kind of the right path. You need to be able to grow these three axes at the same time, roughly. And that's more of a balancing act than engineering, right? Many companies go through these 4 steps that I'm going to introduce, and you will probably see yourselves recognized in any of these, or maybe somewhere in between, right? It's not like a binary distinction across 2 of them. So initially, tools tend to be my laptop, siloed data, takes forever to get it, isolated processes, no impact on key metrics, ivory tower efforts. That's great. You're starting, and that's how you should be starting. I wouldn't rush to grow any of those axes prematurely, right? And we've seen this before many times when you go into one of the extremes for one of those axes, and then everything plummets. The next one is about, well, now you're basically riding a bike, which is great. You have shy decentralization, you may be using the cloud, some static reports, mainly PowerPoint, and that PowerPoint is used for some managers in the business. The relationships can be very heavily transactional, but that's also good because in those transactions you benefit and build some rapport with the business, and the process is barely repeatable. It's not something that you can hit a button on and deploy and basically modify your conversion rate if you were to span a new website tomorrow, right? And governance is poor. You probably don't have metadata end-to-end. You don't have lineage. Obviously, you don't have any of this pretty testing that we were discussing before. But you have moved in the right direction. That red dot tells you that you are in a balanced position close to that diagonal. And that's great, right? The relationships tend to be more transactional because people have seen you writing now, right? So again, big success. Even if that still doesn't feel like it, it's a big success. Then we reach a point where the processes are defined and controlled. Very formally, you know that by doing X, you are modifying your conversion rate by Y%, right? And you can track it and you can justify it, and basically you have the data to substantiate that claim. Your tools are better, and now you have metadata, end-to-end tracking of where the data is coming from, access control, audited. Your reports are still retrospective, but they are live, right? And your relationships, you went beyond rapport. You have some empathy with your business stakeholders, and they allow you to do some incipient experimentation. Early days, right? but they are happy to fail with you. They understood 87% is fine, it's normal, it's a bit of an art, but they're willing to let you try 100 or 1,000 times so that they can see that very limited success, that 13% success rate is exactly what they need to make an impact, right? So I would say this is a good place to be, right, for many companies. And then the final stage would be you're driven by best practice, best of breed solutions, event-driven architectures. You don't do batch unless it's strictly needed. Your processes and how you impact those business KPIs are clear, reproducible. Your data is searchable. They don't come to, hey, Luis, do we have a report for PPC variation over the last year? Like, I don't know. Let me ask someone, right? Classic situation. You have your own data catalog, possibly with a nice business glossary, where people can go and search, and your dashboards, your machine learning models, and your data is there, and you can find what those definitions are and what they mean for the business. Broad accessibility. Everyone in the organization can access data. And there's that level of trust, and you contribute to build it. Wide experimentation. Everyone is doing experiments. Everyone is exploring the data. And, some companies say, hey, well, the analysts are embedded in the business. That's BS, right? You don't need to do that. You need the business to be an analytics business. Everyone is an analyst. And this is the phase 4, right? That we all aspire to get to. So this picture was taken in my home region in a lovely morning in April, right? So as you would say, I know a little bit about the winter, and it doesn't feel like AI winter is coming. It feels like quite the opposite. We have reached that inflection point where we're going to be delivering massive impact to the organizations we work for over the next few years. So, I just wanted to thank you for making this revolution possible with your hard work and all the tooling you're putting together. Thank you very much.
Thank you, Lewis. So, plenty of there to chew on. One thing that sort of came out very loudly for me is in terms of the organizational barriers towards sort of a data culture. Could you perhaps touch on what you think mature data culture looks like and the barriers that are in the way to getting towards that?
I think it is a journey. That's a great question. It's a journey, right? Initially, it depends on what type of company you are. If you're a young digital company, probably you're in a good shape because of all of your data is in the cloud, and the company understands automation and infrastructure as code from day zero. If you're a more traditional organization, 15, 20 years back, I'm not thinking about even more mature, right? Probably you have plenty of legacy systems, siloed data, and it's quite difficult for a company to move out of that mentality initially. Right? So initially, it's about hire the smartest people you can and hire basically the team that can bring all those people on board. You have a system and you have a number of people who have been developing that system over the years. Obviously, they are very protective. It's the baby intellectually. So you come fresh to the company saying, hey, that's rubbish. That's not how you should be doing it. They are not going to be very happy. They are not going to welcome you. For me, it's about building those relationships initially. And by doing that, you tear down the wall, right? So I know I didn't answer to your question, Nick, about what a mature organization looks like, but I think that's step one. Build those relationships and make sure that people welcome you and they ask you to come. And that relationship is not transactional. It's not like, hey, can you analyze this awful, stinky Excel that I've been cooking for the last 10 years? But it's, okay, how do we do it better together? Right?
So in terms of barriers, the barrier could be actually a cultural one, it could be a technical one, it could be that you've got legacy systems that don't lend themselves very well, or Excel potentially being a legacy. So do you see, for example, the role of head of data or director of data, is that the cheerleader then for the kinds of changes that you want to see organizationally?
I think you need to do a bit of that. I'll be quite frank, right? It's not so much a cheerleader, it needs to have substance, right? You can be a nice cheerleader, but again, if you don't deliver, then that trust is gone. Right? You need to be a sociable person. Yes, you need to understand the business. You need to care about what they care about. Yes, that's about building empathy and rapport. And you're not never right or wrong, I guess. You just find a way in the middle, and you learn from each other, and that's how trust is developed. At the same time, I guess people understand lack of technical knowledge, and they smell it from afar. So again, if they don't trust you as a technical leader, at the same time, it's difficult to build that relationship. So it's a bit of a difficult act.
And one of the things that we were touching on earlier was the fact that there's a whole host of skills that are needed within a team, and it's building those skills within your data team, but also within the ops side of things. So presumably there's an educational aspect internally to the organization. You're saying hire the smartest people, but presumably it's supporting them on their journey to learn the skills that they need to learn.
Indeed, and I guess sometimes you don't find that people with the skills that you need, and that's classic problem, right? And you need to be able to grow those skills. I think one of the big learnings for me has been trying to embed your data science team with a product team as early as possible, because that again helps with the relationship building. It helps with the data scientists understanding the business better, and then it simplifies delivery in the long run. I think in the past I probably made the mistake of trying to be in a central team and do our own thing and try to show the way to the business, and that doesn't really work very well, because they like, this, what is this? It may be the smartest thing ever, but I don't have the time to understand what you did. Right?
And in terms of so organizations who don't yet have any machine learning deployments, and are maybe down the curve in terms of what they're actually, or their aspirations, how can you bootstrap a discovery process so that they actually understand the opportunities within their own business for machine learning applications? How can you kickstart something?
That's a good question. I think what we've tried in the past many times, I guess, is to do little lighthouse projects. So you get one data scientist embedded with them, try to understand what the key metrics are, what kind of data they capture, and then you try to bridge the gap between the two. Right? So say you capture web session data. Most companies do, right? Are they doing something with it? Most likely they use Google Analytics or something similar, right? They have some level of reporting. What reports do they look at? What do they care about? Is it conversion rate? Maybe not. Maybe it's just number of sessions, because they are in a growth phase, and all they want to see is that the number of sessions grow year over year. How can you do that? And what I think works very well, and in that specific example, is A/B testing. That is basically more data driven, and they understand very, very well, right? It's A, B, this is differences, and I would probably start there. But
so smaller experiments to bootstrap it and to get the management kind of sort of buy-in to the experiment.
So. Yeah.
And it's very unlikely to actually come into an organization that has all its data well categorized, they actually know what data they've got. So is that also part of this data culture? Is it actually understanding what data you do have in order to analyze and do the experiments?
I think you're right. Would I do it as a single project? Let's say would I set my team to do that over 6 months to categorize all of data? I would say probably not. I would probably get fired before that happened. Or kill myself. I don't know what would happen first. Right?
Don't do that. Sounds drastic.
But I think no, it's obviously a joke. But I think it's again, it's a bit of a journey. When you start exploring the data, you do experiments, you do retrospective analysis, maybe some observational tests on things that happened in the past. That cleaning, that cataloging happens little by little in a natural way. If you have a long-term plan, right? If you're just randomly analyzing things, that's a different matter. But if you have an infrastructure strategy, and first I need to be in the cloud, I need to kill the silos, then I need to add metadata, I need to add the lineage, then I need to make that metadata available in a data catalog so that people can go and search. That if you have that journey a little bit clear in your mind, then things tend to happen naturally. Otherwise, yeah, it's chaos for a while.
Mm. And it sounds like there's a journey there. There's a journey there, whether your organization is small or large. They all have some kind of culture, and it's a question of shaping that culture into what they would like it to be in terms of their approach to data.
Indeed.
Super. Okay, well, Lewis, thanks very much. Will you be on the platform
Of course.
this afternoon? So if you have any further questions for Lewis, then please do reach out, and Lewis will be on the platform, and obviously do connect as well.